movies about projectile motion. And remember that projectile motion is something launched at an angle to the horizontal, or you can be up vertically and then launch something horizontally. But there is an x velocity and a y velocity. So let's kind of trace that again. This would be v, and let's call that v initial in the y direction. And of course, this direction would be vx. You know that that's constant velocity in the x direction. We'll place the origin right here so that y initial and x initial displacements are equal to 0. So let's see what we can do. So we have x sub t is going to equal vxt. So that means the displacement in the x does not depend on gravity. It is a constant velocity. And we find the x displacement by multiplying the constant velocity in the x direction by time. So let's solve for time. Time is then going to be equal x divided by vx. Okay, so what's going on in the y direction? Well, y sub x is then going to equal y sub t, except we're going to plug in x for t. Okay, so how do we get there? Well, we're going to go y sub t equals vy naught sub times t minus 1/2 gt squared, g being the gravity constant. So what we're going to do is we're going to plug in this expression here for where we see time in order to get y sub x. So y sub x is going to equal v sub y naught multiplied by x divided by vx minus 1/2 g, and we're going to multiply x over v sub x. Or actually, we're not going to multiply, we're actually going to square it. Okay, so that's our equation there. So let's group terms together. So y sub x is going to equal vy naught over vx, and we'll put parentheses around that, times x minus, let's have g divided by g times v sub x squared, and we'll multiply that by x squared. So we can see that the position of y, as it depends upon x, is definitely a parabola because we're to the second power, and that way we know it's actually a parabolic motion there. Okay, now we can take the derivative of this expression here. Okay, dy dx. So let's go ahead and do that. So I want to go dy dx equals, well, this is x to the first power, so 1 times this constant here just leaves vy naught over vx, and then x to the 0th, of course we don't write that, minus, well, we're going to take 2 times this constant in front, okay, and it looks like we are missing the 2 from above, so I'm going to kind of squeeze that in there. So the 2 should have also been in this expression. Then the 2's would cross off, so we're left with g over vx squared times x. Okay, so that's the derivative of our displacement function. Now if we plug in x equal to 0, this term here of course falls out, and we're left with v sub y over v sub x. Now if we go back up to our original, v sub y over v sub x is the slope of our beginning velocity vector. So that's what would happen if we were to take the derivative of that and set that equal to x equal to 0. So we have a parabolic motion for sure, and it starts off as a vector. We call that the initial vector, and the slope of that is v sub 0 in the y over v sub x.